I'm Jaime Melis. I'm an OpenNebula developer. I've been a developer for 3 years now. And I'm going to do a presentation on hacking OpenNebula. That means I'm not going to talk about like the whole set of features OpenNebula has and all those things, but it's going to be a bit of a technical talk on how to integrate OpenNebula with your infrastructure. Now, since integration is going to be mostly shell scripting, all those things, you don't really need to know OpenNebula before understanding this stuff. And I think it's going to be easy for everyone to understand it. So OpenNebula, just like CloudStack, it's a cloud management solution. You can do it in private clouds. We have a private cloud API, and you can manage images, networking, you can virtual machine support. And you can also expose public cloud interfaces such as EC2 or our native one, which is OCCI, the Open Cloud Computing Interface. And we also have support for hybrid cloud. That means that we can communicate with Amazon services and do cloud bursting and hybrid cloud computing. Now, what do we expect? OpenNebula does what we would expect from a cloud management solution. That is, it manages, of course, virtual machines, but it does as well manage storage backend. So you register your image, it goes into a data store, and then when you launch the cloud VM, it gets moved back and forth. And we have support for many backends and things. Now, we also have support for different kinds of networking. We have the VLAN installation, Open vSwitch, we have firewalling, we have UV tables, and many things, and all those things can be easily extensible. Of course, we expose many APIs. We have, like Sebastian said, a very powerful command line interface, because OpenNebula is a very Unixy tool. So even, for example, permissions on the resources are done in the Unix way. You declare a group owner, a user owner, and then permission object. And that's how it works for every single resource OpenNebula manages. We expose, we have a web interface. We have public cloud interfaces, as I said before. Now we also have multi-tenancy. That means that we are very scalable in the sense that we can deploy many OpenNebula clouds. There's a server, we call it also, and it's running on top of that. That will federate all those OpenNebula instances. I will give you virtual data center, so you can do whatever you want with that. You have the virtual data center admin, and he has access to a certain part of that, to a specific set of OpenNebula resources. And we also support grouping of clustering, monitoring, and multiple hypervisors. Now, to understand why OpenNebula is designed the way it is, I think it would be important to explain a set of principles we follow every time we create a feature, and which have determined the way OpenNebula works nowadays. First of all, we try to be really flexible. That is, we don't think there is one, each data center is different. So instead of trying the data center to behave like we want it to behave to, what we give is sysadmins and DevOps the means and tools to adapt OpenNebula to work with their infrastructure. So if you have a heterogeneous infrastructure, you have a proprietary component nobody's integrated with, we just we try to work with that easily and seamlessly. So components are easily hacked. It's your batch, and you can simply look at them, understand them like a couple of minutes, and then you go write the extension. That's the message I want to get across in this talk, that it's really, really hackable and it's really simple. It's simple. Although we have many features, we manage many virtual resources, that doesn't mean we have many components. Actually, everything runs in one machine, except for hypervisors, which have their own server. It's scalable, as I said before. It's interoperable, and it's open source. This slide, I think, shows beautifully how OpenNebula works. This is OpenNebula deployment, a real deployment. You have just one OpenNebula node. It has the OpenNebula daemon, the scheduler, and that's it. You don't need any agents in your nodes. You don't need anything. Just as long as those agents have a hypervisor and have an SSH, OpenNebula will communicate with them So to getting started with OpenNebula is really easy. Just install OpenNebula in your front end and your. So this is the OpenNebula's architecture. In the center you see the OpenNebula core. That core is written in C++. That core is responsible for orchestrating the life cycle of all the resources, such as images, templates, virtual machines, all those things. On top of that, we have an XML RPC API. Clients, all the clients, even the scheduler uses that XML RPC API. We have official bindings for supported by us, by Ruby and Java. We have community contributions for Python, even for PHP. And even though, since it's an XML RPC API, it's very easy to abstract and to create a library for OpenNebula. On top of that, we have the command line interface, the GUI, which is, we have two GUIs. We have the public cloud one, and the private cloud, which is Sunstone. And below OpenNebula, below the core, this is going to be my main topic today, which are the components that you can extend and customize to your data center. So I'm going to move on to the virtual management drivers. There are three things about this set of drivers. They're easy to adopt, and they're so easy to maintain because you can understand them really easily. So if if you have to upgrade OpenNebula, you can simply port them. You can see we have a migration document every time. You can see what has changed, and then you can simply plug it into your new OpenNebula installation, reusing all the integration effort you have already done. So moving on to the virtualization drivers. These are the drivers that are responsible for the virtual machine actions, such as deployment, canceling, shutting down, and stuff. We have support for 4 hypervisors in the main distribution: KVM, Zen, and VMware. Each of them, they have the same features and they behave similarly. And Amazon Web Services, which is for hybrid computing, it behaves a little bit differently because the concept is different. But then again, the concept is the same. And we also have many community contributions that some of them are maintained, some of them aren't. So you can use another VirtualBox and all those things. Now, this is the most, I guess this is the most difficult slide of the talk. It's how does the deployment in OpenNebula work? This is an example of the deployment flow for KVM. On the left side, you can see the core, the blue box. The core will generate the deployment file. That's the black box on the left. That's a typical libvirt deployment file. You don't see anything strange in there. The core sends that deployment file over the standard input to a remote KVM deploy script that is in the hosts. So when OpenNebula bootstraps a host, it will send to that host some static scripts, and those will be called during the OpenNebula life cycle, during certain specific actions. What you see down here is the entire deploy script. Well, there are a few lines missing, but they're mainly source, sourcing other files. But as you can see, deploying, extending this is really easy. The first bullet line that says cat to domain, that's writing down the deployment files that it got from the front input to the domain file. The next line is doing a verse, create a domain. So it's as simple as that. As long as you know what your hypervisor works, as long as it has an API, command line interface, you're good to go. It's as simple as that. So that's what it does. It writes a deployment file and it does verse create, and it reports back to OpenNebula the status of that call. So it's really easy to understand. This is the set of different actions you have to implement to have a full support for a hypervisor. So you have they're pretty much self-explanatory: shutdown, restore, reboot, all those things. This, for instance, to the right is an example of a migration script. As you can see, this is the complete migration script. We just source a few lines and we do extend migrate. This is for Zen hypervisor. It just couldn't be simpler. If you want to tune a few lines there, it's it's really easy to do. So a while back, we created 3 appliances, such as the one CloudStack provides. So you can just boot OpenNebula into your download an appliance and start it with VirtualBox, KVM, and VMware. We have those 3. But again, what we did is that we created an Amazon instance. So you can go into Amazon, you can start an Amazon instance which has already OpenNebula installed and running, and it will virtualize within that Amazon instance TTY Linuxes, not by using KVM, but using QEMU, because of course you can do KVM instead of Amazon, since it's since you can't have virtualization inside of that. So what we have to do, we have to write support for a new hypervisor, which is QEMU. Now that's not included in the physical distribution, because nobody would want to use that having KVM, since it doesn't have virtualization extensions. But these are the steps we had to follow to provide support for QEMU. We cloned the set of drivers for KVM to a folder named QEMU. And now the second point is that in the deployment file that I showed a couple of slides earlier, we substituted KVM with QEMU using a set command, and then we piped that to the deploy. So the gray box down on the left, as you can see up there, it says domain type equals KVM. So what we did is we wrote a script that is the QEMU deploy script, that in turn will call the deploy script that will change the standard input, capture it, and change it that type equals KVM, type equals QEMU. And then we call the KVM deploy script. Third thing we have to do is the pulse script, which is a very simple script that is written in Ruby, because it collects some information from the hypervisor. We have to change one line for it to detect QEMU. So that was the whole story for creating support for any hypervisor. Now, of course, if you're going to create support for any hypervisor, it's going to be a little more difficult like this, because QEMU is really similar to KVM. They use the same deployment file with a few exceptions and all those things. So instead of doing this, you would mainly need to tune all the other scripts and do those things. But the point is that if you know how your hypervisor works, if you know how to deploy a deployment file, how to cancel, how to do all those things, it's just a matter of following a few steps, and then you have support for any hypervisor. Therefore, OpenNebula is extremely integratable. I'm going to talk about the storage subsystem. Storage subsystem, we have in the distribution, we have support for shared file systems, of course, NFS, cluster, whatever you want. We have support for LVM and for iSCSI. To be honest, those two, they work very good, and they work very good because we had many contributions from lots of people using those ones, and we've included all those patches they sent us. And right now, they work beautifully. We have support for SSH and for HTTP, so you can have an image in a web server, and you simply pass it along the template of the virtual machine, and it will just work. We also had some community contributions. Those are not included in the official distribution, but they were at some point by people who I don't know if they're maintaining them anymore. But it's really easy, because it's really easy to hack new support for new storage packets. So this is a bit tricky. In OpenNebula, we have a separate set of drivers. We have divided the image storage image drivers into two logical sets: the data store drivers and the transfer manager drivers. Data store drivers are the one that take care of putting the file in the equivalent to an object store. So if you want to use an image within OpenNebula, you have to register the image, and it will go to an object store or a file system or whatever it is. Those are the scripts on the left. CP, it's for registering, copying. Stat will return the size, and make a file system will create a new empty one, clone, remove, and those things. And the transfer manager will take care of the part of moving the images from the object store to the virtual machine directory, which will be executed by the hypervisor. So I've chosen this example of the registration script of a volume to the iSCSI backend. The iSCSI backend in OpenNebula, we're assuming people have it installed in a Linux box with TGT. So what it does, there's a few lines missing, but again, they're not really relevant lines. We are sticking up information, gathering variable names, and doing all the stuff. So what it does, OpenNebula sends to the, it calls the iSCSI CV script locally to the front end. This time it's not done via SSH. And it's an REP event, not by standard, but it's sending the template in base64. So this script, what it does, and some lines above, it will decrypt that, decode that base64 in the template, will extract a few variables that depend on the user input, depending on how you create the template. And what it will do is as simple as SSHing. This script, what it will do is SSHing into the host, the destination host, the one that has the iSCSI backend. It will create an ULD, it will set up the LAN, and it will dump the configuration so in case the server reboots, it won't be lost. Now, there's the SSH executable line, it will run the command. And then the last line is it's dumping the contents of the image file to the destination's block device. So we do that with DD. So pretty straightforward Unixy tools. Anything you want to do, as long as you know how it should work, how to get from A to B, how to register it in iSCSI, you can automate that within an OpenNebula script. Now, networking works in a very similar way. We have VLAN tagging. We have OpenVSwitch support. We have for EV tables. Those three are for isolation mainly. We have flat networking scheme and support for firewalling. The structure of these network drivers is only 3 scripts per network driver. So if you have VLAN, for instance, that means you have to implement pre, post, and clean. Pre is run right before the image starts, the virtual machine starts. Post is run right after the virtual machine starts. And clean is spent to clean up all the when you cancel the VM. So this is an example of the pre script that's run right before right before the image is deployed. With a VLAN tagging, regular VLAN tagging. So again, it's the same flow as always. The core sends a template via parameters to a script that it's remotely in the host, and it executes this script. This script will create a bridge, tag a physical device, and plug it into the bridge. So when the machine boots up, it will find a bridge that is already configured and working, and by simply plugging the virtual network interface into that bridge, you will have VLAN tagging. These scripts are written in Ruby, not because they can be written in Bash, but because there were some inheritance things we wanted to do. So there are many stuff in common, and we figured that by inheriting classes it would be much easier. But this is the whole this is the whole heart of the matter. You have you can grab the VLAN from the configuration file from the instance from the virtual machine template. You create the bridge. You create the tagged physical interface, and you attach it. Each of these Ruby lines introduces itself to a regular Unix code like vconfig or ifap or IP or whatever you want. I'm going to skip the authentication thing because I don't have much time left. But we have for authentication, it's also very extensible. We have integration for LDAP Active Directory. We have SSH keepers authentication. We have support for ACL quotas. All this is extremely extensible. We can hash a new contribution, a new authentication driver really easily. Now, I want to show you a quick example of how the OpenNebula Ruby bindings work. This is a whole script that it connects to the OpenNebula and iterates through all the virtual machines that you can see and shuts them down. First line, you require telemetry. Then you have the 8th line, you define the client. The next line gets the pool, and then in that for loop, you just simply iterate through each virtual machine and send it the shutdown method. And there you go. That's Ruby API. Super simple, and it's really easy to do many things with it. Also, as an example of how to integrate, how integration can be done on top of OpenNebula, extending using OCA OpenNebula. A few days ago, we released 3 more applications that sit on top of OpenNebula. Flow will manage services, so you can define a service like in a JSON. You have 2 nodes, the front end and the DB and a database. You launch them, and it will manage all those things. So you have a complete service management. Do rollbacks, and do whatever you want. Upstage, which is you have like dynamic templates with Chef installed. So if you want to configure, so if you have like an image that supports the Chef, you can install the WordPress dynamically by supplying a configuration file. That's pretty good. And they have market that lets you host your own marketplace. The marketplace is a web interface where you can register OpenNebula appliances and download them directly to OpenNebula. So if you like OpenNebula and you want to contribute there, many ways you can do that. Of course, using OpenNebula is the most important one, giving us feedback. We love that. Our app mailing list is very active. There are many interesting discussions going on there. Many people who are deploying OpenNebula using really big data centers, and they're contributing ideas about how to deploy those things, how to make it better, and all those things. You can, of course, report bugs, request features. You can translate OpenNebula. OpenNebula has been translated to the community, by the community into 17 languages. You can make components. You can do whatever you want. My favorite one, if you're a package maintainer, please come talk with us. We need package maintainers. You can find us in the free node, in the OpenNebula channel. Now, this is what you need to do to download OpenNebula and try it. Is you go there and you can download 3 appliances, or go to the Amazon one and use it. And use it, and it will be already ready and running TTY Linux inside of it. I'm just promoting a few more talks we're going to do in a while. Next talk is also about OpenNebula by Sishan, so please stay. And then we have a 12 o'clock one about CentOS and OpenNebula, why that's a very good combination. And Raindrops is a service that it's not exclusive to OpenNebula, but any cloud manager will want to use it, because it lets you send an image, you send a kickstart file, and it will give you back in a couple of minutes an image where you can download that, an HTTP path where you can download that image from. So thank you very much, and if you have any questions, I'll be glad to